This is a lecture on 8-3, t-test for a mean. A t-test is a hypothesis test to inference about a population mean when sigma is unknown. It is a hypothesis test that is very similar to a z-test, and at this point I'm under assumption that you understand the idea of the hypothesis tests and the theory of the hypothesis test. So if you don't quite understand what's going on, please revisit 8.1 and 8.2 where we discuss the basics of the hypothesis testing. A t-test has its own test statistic. And it is described by t, which is x bar minus mu divided by s now over the square root of n. Note it is very similar to a z-value, except the degree of freedom is equal to n minus 1. What we're dealing with is it's a normal distribution, but now it looks slightly different. It's not as tall and much wider, and the tails are much bigger. In order for me to find the critical values in t distribution, for example, alpha at 0.05, right tail, this is the picture. There's two ways to go about it. Either you can type in inverse t, 0.05 and the degree of, I'm sorry, not 0.05, 0.95 and 16 for the degree of freedom, or you can look it up under a table. If you do not have an inverse t function on your calculator, it is possible to avoid finding the critical value. All you're going to do is you're going to use a p-value method rather than a traditional method when looking at the hypothesis testings. The assumptions for using a t-test is normal distribution. So random sample, n is greater than 30, or you must have a statement of normal distribution. And we're going to be using this test when sigma is unknown. Really, in this book, this is the only thing that distinguishes the z-test from a t-test. My first example uses a data set. A medical researcher found that people who take aspirin take on average 8.6 tablets a week. So they gave me the fact that we are looking at an average. A medical doctor wanted to see if he could reduce the number of aspirin tablets a person consumes if the subjects practice yoga twice a week. A random sample of 12 people who take aspirin were taught yoga, and after a 12-week period, a doctor found that they took the following number of tablets for 1 week. So, in order for me to do this, this is a hypothesis test. All of the steps are similar to steps that we've taken in 8-2. And we're going to start with the null hypothesis and the alternative hypothesis. This is the average, so I need to have a mu. I must have an equal to, and whatever the research showed on average. So this is that 8.6, that's right there. A medical doctor wanted to see if he can reduce The word reduce will tell me that this is a one-tailed test, that the mu is trying to be less than that 8.6. A random sample of n people. So this tells me n is equal to 12. And I'm not given anything else. All I have is a sample. In order for me to run this on my calculator, I'll click Stats, over to Tests, your tTest should be your second one. Then because you have a data, you have to select data. At this point, the data should be entered under L1, so you can go into Stat, Edit, and then Edit, and you should have it in L1. So if you enter the data in L1, when you choose your t-test, the data should already be there, and by default L1 should be already under list. The mu sub 0, that's the null hypothesis. You will put 8.6. And then you have to make a decision between a left tail, two-tail, left tail, or right tail. This is a left tail test. So I'm choosing mu is less than 8.6. And you push the button calculate. What the t-test does, it calculates a few things. First of all, it'll give you the test statistic. That's the second thing that you see. Negative 2.58. 2 decimal places is plenty. The next thing you see is the p-value. Don't write it as a p, write it as a p-value because we already have labeling for p. We probably want a few decimal places here, so maybe 3. And then it actually calculates the one variable statistic because this is a list. A list has its own x bar, which is 8.63, and it has a standard deviation, which is 2.37, rounded correctly, and is equal to 12. So this is the stats that it calculated. So it calculates the one variable statistic right there for you when you're running a test. It looks up all the critical values, it looks up all of the tails, and all you have to do at this point is compare this to alpha. The p-value is equal to 0.013. So since they didn't give us the alpha for this particular example, you can either make one up, or we can take a closer look at the book, or you can use alpha 0.05 by default for all of them. So in this case, the alpha was given to you at 0.1. So notice 1.3% is certainly less than 0.1 alpha. If p-value is less than alpha, you reject the null hypothesis. You must include complete sentence every time you're doing this. So you reject the null hypothesis. And well, we're trying to see where's the claim. He's trying to reduce the number of aspirins. So did he manage to do that? Yes, he did. We reject the null hypothesis in favor of the alternative hypothesis, where the data shows that yoga reduced the weekly aspirin intake. The most important thing is that final sentence. Let's take a look at another example. A physician claims that joggers' maximum volume oxygen uptake is greater than the average of all adults. The random sample of 15 joggers has a mean of 40.6 milliliters per kilogram and a standard deviation of 6. If the average of all adults is 36.7, is there evidence to support the physician's claim at alpha of 0.05? Assume the variable is normally distributed. So we kind of need this information right here, the normal distribution. We needed it here, normal distribution. So these are the things that we need to assume in order to even run the test, or you can't run the test. So let's do this one. Step 1. Identify the null and alternative hypothesis. Physicians claims the jogger's maximum volume uptake is greater than the average of all adults. A random sample of 15 has a mean, so that's the mean of the sample. See, a sample of 15 has a mean of 40.6. And the standard deviation. So again, the sample standard deviation. So they didn't give us a population standard deviation, they gave me a sample standard deviation. This is how you know that you're going to be running a t-test. If the average of all adults is 36.7, so the average of all adults is 36.7, so this is your null hypothesis. The mu is equal to 36.7. The alternative hypothesis, and then I'm going to be looking for words like less than, greater than, or neither one. So in this case, the physician is trying to claim that the jogger's maximum volume oxygen uptake is greater than the average adult. So we're going to see that this sample that we've gathered should be greater than 36.7. So this is the claim that the physician is trying to make. My step 1, I have my hypotheses listed. Step 2 is write down the necessary statistics. State the test and identify the degree of freedom. The degree of freedom is always n minus 1, so in this case it's 15 minus 1, which is 14. This is something that I probably should have included right here as well. So the degree, if n is equal to 12, the degree of freedom has to be 11. Don't worry remembering the steps, because all of the steps are going to be outlined and given to you during the test, and it's a handout that will be available to you or is available to you on Canvas. At this point, we're ready to run the test. For stat, over to tests, click tTest, choose stats because you're given statistics. Under mu sub 0, you will put 36.7. Under X bar is the information that they gave you is 40.6. Under S, you will put 6. It's asking for N, so you're going to enter N is equal to 15. And then you're going to choose a right tail test. So you're going to choose greater than mu sub 0. and then push calculate. What it's going to spit out is the one variable statistic, which we already know, and the test statistic and the p-value, and that's what you need to write down. The test statistic is 2.52. If you would have a critical value, then you would be able to compare this using a traditional method. But because we have a calculator, the p-value is spit out for us as well, is 0.012. And now you can compare this to an alpha that is given to me at 0.05 within the problem. If p value is less than alpha, you can reject the null hypothesis, saying there is enough evidence to support the physician's claim. And I'm basically copying the original sentence down in the beginning of the problem. Physicians claims that joggers maximum maximal volume oxygen uptake is greater than the average of all adults. On the next video, I'll show you how to do this on the calculator if you still have questions.